Introduction.
See those holes on honeycomb.
Yeah, how beautifully the bees make honeycomb.
Have you noticed the holes in that? They're in pattern.
Hey, yes, they form a pattern.
In nature we can find so many things with patterns.
Things like,
Things like pine cone.
wow, I never noticed this pattern before.
Our maths teacher taught us about one of these patterns in which succeeding terms are obtained by adding a fixed number to the preceding terms.
That sounds interesting. I also want to know about such type of patterns.
Okay, I'll tell you more about it.
Objectives. At the end of this lesson, you'll be able to explain arithmetic progression, define term and common difference, write the general form of AP, find the nth term of given AP, find the sum of first n terms of the given AP, and solve examples related to AP. Definitions 1. In nature, many things follow a certain pattern, such as the seeds of a sunflower, the spirals on a pineapple, the pattern on cactus, and so on. Arithmetic progression is a study of one of such patterns. The arithmetic progression can also be called as arithmetic sequence. Before talking about arithmetic sequence, let us know what a sequence is. A sequence is a set of numbers that follow a pattern. We call each number in the sequence a term. Look at this example of sequence. This is the first term. This is the second. This is the third, and so on. An arithmetic progression is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. This fixed number is called the common difference of the AP. Look at this sequence. We can see here that the common difference is 3. In general, we can write an arithmetic sequence like this: A plus D, A plus 2D, A plus 3D, and so on, where A is the first term and D is the difference between the terms, which is called the common difference. Definitions 2. Look at this example now. We can see that this sequence has a difference of 3 between each number. Therefore, A is equal to 1, the first term, and D is equal to 3, the common difference between terms. Let's form the sequence using A and D. We know AP is equal to A plus D, A plus 2D, A plus 3D, and so on. Substituting the value of A and D, we get 1, 1 plus 3, 1 plus 2 into 3, 1 plus 3 into 3, and so on, which gives the sequence 1, 4, 7, 10, and so on. There are two types of arithmetic progression: finite arithmetic progression and infinite arithmetic progression. The arithmetic progression having a finite number of terms, or which has a last term, is called finite arithmetic progression. And arithmetic progression having infinite number of terms, or which does not have a last term, is called infinite arithmetic progression. Here are some examples of infinite arithmetic progressions. Look at this sequence now. Can you tell its common difference? Yes, you're right. Its common difference is minus 3. In general, for an AP, A1, A2, and so on till AN, we have D as AK plus 1 minus AK, where AK plus 1 and AK are the K plus 1th and the kth terms respectively. Example. Let us now solve some examples. Observe this sequence. We will find out whether these numbers form AP or not. Here A1 is minus 3, A2 is 3, A3 is minus 3, and so on. Now let's find A2 minus A1, which is equal to 3 minus 3, which is equal to 3 plus 3, which is 6. Also, A3 minus A2 is equal to minus 3 minus 3, which is minus 6, as A2 minus A1 is not equal to A3 minus A2. The given sequence is not an arithmetic progression. Nth term of an AP. If the initial term of an arithmetic progression is A1 and the common difference of successive numbers is D, then the nth term of the sequence is given by An is equal to A1 plus n minus 1 into D. We know that An is also called the general term of the AP. If there are m terms in the AP, then Am represents the last term, which is sometimes also denoted by L. Now by using the formula of nth term, let's find the 8th term of the given AP. Here A is equal to 2, D is equal to 7 minus 2, which is 5, and n is equal to 8. We know that An is equal to A plus n minus 1 D. So, A8 is equal to 2 plus 8 minus 1 into 5, which is equal to 2 plus 35, which equals 37. Therefore, the 8th term of the given AP is 37. Example. Find the sum of the first 40 terms of the AP, 2, 4, 6, so on. We can see that given series is an AP with first term A is equal to 2 and common difference D as 2. We have to find the sum of first 40 terms. So, n is equal to 40. We know that S is equal to n upon 2 into 2A plus n minus 1 into D. Hence, S40 is equal to 40 into 2 into 2 plus 40 minus 1 into 2 by 2, which is equal to 1640. So the sum of the first 40 terms of the AP is 1640. Find the sum of the first 1000 positive integers. Let S is equal to 1 plus 2 plus 3 plus so on plus 1000. Using the formula for the sum of the first n terms of an AP, we have Sn is equal to n upon 2 into A plus L. Substituting the value of n, we get S1000 is equal to 1000 upon 2 into 1 plus 1000. This is equal to 500 into 1001, which becomes 500. So the sum of the first 1000 positive integers is 500. Find the sum of first n positive integers. Let Sn is equal to 1 plus 2 plus 3 plus so on plus n. We can see that here A is equal to 1 and the last term L is n. Therefore, using the formula Sn is equal to n upon 2 into A plus L, we get Sn is equal to n into 1 plus n whole upon 2, or Sn is equal to n into n plus 1 whole upon 2. So, the sum of first n positive integers is Sn is equal to n into n plus 1 whole upon 2. Find the sum of first 19 terms of the AP whose nth term is 2n plus 1. As the nth term an is 2n plus 1, so first term a1 is equal to 2 into 1 plus 1 is equal to 3. Second term a2 is equal to 2 into 2 plus 1 is 5, so on. And 19th term is equal to 2 into 19 plus 1 is equal to 39. So the list of numbers we get is 3, 5, 7, so on, 39. Now to find S19, we have n as 19, a as 3 and L as 19. Therefore, S19 is equal to 19 upon 2 into 3 plus 39. This is equal to 19 upon 2 into 42, which equals 19 into 21, which is equal to 399. Hence, the sum of first 19 terms of the given AP is 399. Did you know? The nth term of an AP is the difference of the sum to first n terms and the sum to first n minus 1 terms of it, that is, an is equal to Sn minus Sn minus 1. Summary. Let us summarize what we have learned. An arithmetic progression AP is a list of numbers in which each term is obtained by adding a fixed number d to the preceding term, except the first term. The fixed number d is called the common difference. The general form of an AP is a plus d, a plus 2d, a plus 3d, and so on. In an AP with first term a and common difference d, the nth term or the general term is given by an is equal to a plus n minus 1 into d. The sum of the first n terms of an AP is given by s is equal to n upon 2 into 2a plus n minus 1 into d. If L is the last term of the finite AP, say the nth term, then the sum of all terms of the AP is given by S is equal to n upon 2 into a plus L.